So let's start. Today, I will be talking about neurophysiological studies on altered states of consciousness. In recent decades, there has been a growing interest in the research on altered states of consciousness in both psychology and neurophysiology. Nowadays, the most frequently neurophysiologically studied examples of altered state of consciousness are human creative activity, meditation, and the effects of psychoactive substances. In this report, we will discuss the neurophysiological correlates of the above-mentioned conditions and consider whether they have anything in common so that we can integrate this data into some kind of consistent concept, if it's possible. So next slide, please. And first, we must define what an altered state of consciousness is. To do this, we must understand what normal, ordinary states of consciousness are. From my point of view, the most correct definition of this concept was given by the famous scientist Stanislav Grof. He wrote that normal states of consciousness are characterized by the presence of spatial and temporal limitations. That is firstly, in normal states of consciousness, a person always perceives himself as existing within the boundaries of his physical body, which clearly separates him from the rest of the world. And secondly, a person can experience only those things that are happening at the moment. The principle of here and now. The main characteristics of altered state of consciousness is that the spatial and or temporal limitation is exceeded. That is, a person experiences a weakening or disappearance of these limitations. Based on Grof definition, it is possible to build a whole hierarchy of altered states of consciousness, starting with such, for example, states as coma, sleep, general anesthesia, and finishing with creativity, meditation, religious and mystical experience. Please, next slide. Thank you. Let's start looking at the neurophysiological correlates of altered state of consciousness through my favorite subject, creativity. Creativity can be generally considered as the ability of an individual to generate new, original ideas, to deviate in thinking from stereotypes and traditional patterns and schemes, and to solve problem situations quickly. Nowadays, the study of brain organizational creativity is one of the priorities of modern psychophysiology. The following paradigms are actively used. The first, divergent thinking, both as a holistic construct and as a study of its separate parameters, flexibility, fluency, and originality. Divergent thinking is a thought process used to generate unusual creative ideas by exploring many possible way solutions. The second is remote associations. Remote associations is the ability to link concepts that were relatively remote into new relationships in a new concept. The third is insight state. Insights is a term used to describe a deep understanding of particular subject, things, or situation. It's the ability to see beyond the surface level and identify the underlying factors that contribute to a specific outcome. And insight is often associated with intuition, as it involves a level of understanding that is not necessarily based on logic or evidence. And the last, it's imitation of the real creative processes, such as drawing, composing music, writing poetry, even dancing, and so on. Neurophysiologists are also trying to find functional brain differences in people with different types of creativity. These are studies of representatives from different creative professions, and in people with different level of creative ability, so-called high and low creative subjects. In spite of large number of subjects in the study, they demonstrate the presence of relatively contradictory points of view on brain organization of creativity. So it's difficult to integrate all the experimentally obtained data into consistent concept of brain organization of creativity. But we will try to formulate this concept based on our many years of researching brain mechanisms of creativity. We have been studying the brain organization of creativity for 25 years. And it was my scientific supervisor, academician Bekhteva, who first started the neurophysiological studies on creativity in Russia. We used different types of original verbal creative experimental tasks with adequate control conditions, and each type organizing creativity in its own way. There were around 700 subjects who participated in our investigation using EEG, PET, and fMRI methods. Let me briefly remind you the essence of these methods. The electroencephalogram, no, it's not. Yeah. The electroencephalogram EEG is a registration recording of spontaneous general electrical activity of neurons in the cerebral cortex from the surface of our skull over a certain period of time. Positron emission tomography PET measures the regional cerebral blood flow, and functional magnetic resonance imaging fMRI measures blood oxygen level dependent signal, so-called Volt signal. Now, with the next slide. So, let's return to the brain organization of creativity. The first important fact is, in a certain sense of word, we can say that creativity is maintained by the whole brain. You can see the areas of activation marked in red on this slide. The fact that the whole brain is being activated while performing creative activity can reflect the overcoming the memory matrix of stereotypes which are built into our brain for the correct performance of everyday routine, including intellectual ones. When faced with the need to act in a non-standard way, this whole brain activation serves for adaptation to such a situation, because the stereotypical matrix does not provide the solution. It is primarily reflected in EEG observation, mainly in the dynamics of the alpha, beta, and gamma frequency bands. This might reflect the differences in the functional brain states which are necessary for the successful performing of the different types of creativity, like divergent thinking, remote associations, insight, and so on. Please, next slide. The second important fact is that there are certain brain areas which are sensitive to any kind of creative activity, irrespective type of task, or cognitive strategy, or personal features, or environmental conditions, or situational factors, and so on and so on. I mean, the constant presence of prefrontal and parietal areas during performance, the various types of creative tasks. But the role of these areas in the creative processes is different. The parietal area is responsible for generating new, original, unusual ideas through the imagination. The prefrontal cortex is a very important area. It performs a lot of functions in our brain. And the most important of them is cognitive control, any physical and mental activity, including creativity. Please, next slide. The next fact is there is a complex functional interaction between prefrontal and parietal areas during creativity. Functional interaction or functional connectivity can be defined as the statistical association among two or more anatomically distinct areas. In other words, functional connectivity shows how activity in one brain structure affects the activity in another. Accordingly, the connection between different parts of the brain can either weaken, decrease functional connectivity, or increase functional connectivity. We discovered an interesting fact. In simple creative tasks, functional connectivity between the frontal and parietal cortex are increased. You can see these marked with red colors. But the functional connectivity decreases among frontal and parietal areas with the complication of creative activity, marked with blue color. Revealed decrease in functional connectivity reflects diminution of cognitive control, so that the parietal area can generate new ideas for successful solving of creative tasks really. That is, in order to maintain successful creative activity, it is necessary, in a certain sense of the word, to reduce the activity of the prefrontal cortex, turn it off. Please, next slide. So, let's summarize the information about the brain organization of creative activity. Creative activity is maintained almost whole brain. That is, a large number of its areas are activated. To successful performance of creative activity is required a certain level of cortical activation, certain functional state, which is reflected in dynamics of alpha, beta, and gamma activity. Frontal and especially parietal areas are sensitive to any kind of creativity and constantly work during creative activity. There is a complex functional interaction between frontal and parietal areas during creativity. In particular, decrease in functional connectivity among frontal and parietal areas reflect diminution of cognitive control. Please, next slide. So, now let's look at the neurophysiology of meditation. Meditation neural correlates vary with level of expertise, length, and nature of practice. Nowadays, the most researched types of meditation include focused attention meditation, open monitoring meditation, non-dual meditation, and loving kindness meditation. Usually, focused attention meditation is the starting point for any novice meditator. During focused attention meditation, the person is required to focus attention on a chosen object or event, for example, such as breathing or, for example, a candle flame. To maintain this focus, the person has to constantly monitor the concentration on the chosen event, so to avoid mind wandering. When persons become familiar with the focused attention meditation technique and can easily sustain their attentional focus on an object for a considerable amount of time, they often progress to next stage, to open monitoring meditation. During open monitoring meditation, the focus of meditation becomes the monitoring of awareness itself. In contrast to focused attention meditation, there is no object or event in the internal or external environment that the person has to focus on. The aim is rather to stay in the monitoring state, remaining attentive to any experience that might arise without selecting, judging, or focusing on any particular situation or object. To start, however, the person will focus on a chosen object as in a focused attention meditation, but will subsequently gradually reduce this focus while emphasizing the activity of monitoring of awareness. Loving kindness meditation incorporates elements of both focused attention meditation and open monitoring meditation. Person focus on developing love and compassion, first for themselves, and then gradually extend this love to ever more unlikely others. For example, from self to a friend, to someone one does not know, to all living beings, and so on. Any negative associations that might arise are supposed to be replaced by positive ones. And the last, non-dual meditation. The key component of this type of meditation is that one aims to discover an awareness that is unchanging regardless of what happens in experience. Some historians propose that this style of meditation was developed later in time than focus attention on and open monitoring meditation, based on emphasizing the idea that there is an awareness that is beyond the subject observing experience, that is implicated in focus attention and open monitoring meditation. Clearly, focus attention and open monitoring meditation still have embedded within the practice the duality between an unconditional observer and objects that are observed, used as a final release of any abstraction away from the here and now in non-dual meditation, the idea that there is a distinction between self and object of experience also falls away. For example, by realizing that subject and object always arise together in experience. This results in a state of awareness in which there is no background or foreground of experience, that is hence devoid of concepts such as self and objects, intentionality, or the experience of time and space. For example, a state in which even the most basic construct of cognition no longer persists. Next slide, please. When analyzing the neurophysiological correlates of meditation, of all types of meditations, we discover a pattern similar to neurophysiological pattern of creativity. EEG correlates of meditation mainly associated with changing in the alpha, theta, and gamma frequency bands. All the types of meditation are associated with global increases in oscillatory brain activity in meditators. For example, while focused attention and open monitoring meditation are related to increase in anterior theta activity, only focused attention meditation is associated with changes in posterior theta oscillations. Alpha activity increases in posterior brain region during both focus attention and open monitoring meditation, and in anterior regions, focus attention meditation shows a bilateral increase in alpha power, while open monitoring meditation shows a decrease only in left-sided power. Gamma activity in these meditation practices is similar in frontal regions, but increases are variable in parietal and occipital regions. The alpha activity is associated with relaxation and memory consolidation. Theta band is related with focused attention, cognitive processing, and memory. And the gamma activity is associated with complex cognitive states such as attention, working memory, perception, being also related to information processing. Next slide, please. fMRI studies have demonstrated the various types of meditation increase activity in different regions of the whole brain, including the prefrontal, parietal, cingulate cortex, and hippocampal area. Different forms of meditation can activate different regions of the brain. For example, focus attention meditation results in increased brain activity in the anterior cingulate cortex in relation to open monitoring meditation. Focused attention meditation is also associated with increased right prefrontal activity, which has not been seen in open monitoring meditation. In addition, both focus attention and open monitoring meditation demonstrate increased fMRI signal in the posterior insula. Please, next slide. Most meditation practices, including focused attention meditation, open monitoring meditation, and love-kindness meditation, are thought to deactivate the default mode network of brain DMN. The default mode network is a group of brain regions which has a self-referential nature, including parts of the prefrontal cortex, cingulate cortex, parietal cortex, temporal cortex, and the hippocampal formation. It can be considered as the baseline state of the human brain in internal modes of cognition. DMN is active during passive awake rest, when persons are engaged in internally focused tasks, such as autobiographical memory retrieval, thinking about the future, and taking perspective of others, and so on. The default network may contribute to the use of past experiences to plan for the future and maximize the experience of not being engaged by the external world. Meditation decreased activity in the main regions, probably due to reduced mind wandering. Regarding the results of functional connectivity, it is shown mostly the increase in functional connectivity among different areas of prefrontal cortex as well as prefrontal, parietal, and cingulate cortex during the meditation. The overall increase in functional connectivity and activity of the prefrontal cortex may explain the decrease in anxiety, depression, perceived stress, negative emotions, and hyperarousal symptoms in meditators. Next slide, please. Some important aspect of meditation is mindfulness. Mindfulness-mediated functional connectivity changes include increased connectivity between cingulate and prefrontal cortex, which may relate to attention control. Decreased connectivity between occipital cortex, which may relate to self-awareness. Increased connectivity between cingulate cortex region and prefrontal cortex, and decreased connectivity between anterior cingulate cortex region and amygdala region, both of which may relate to emotional regulation in our brain. And lastly, increased connectivity between cingulate cortex and insula, which may relate to pain relief. Please, next slide. So, let's summarize the information about the brain organization of meditation. We observe activation almost the whole brain. That is, large number of its areas are activated during meditation. EEG correlates with meditation mainly associated with changes in the alpha, theta, and gamma frequency bands. Most meditation practices deactivate the default mode network. Please, next slide. So, it remains for us to consider the neurophysiological correlates of psychoactive substances. Classic psychedelics, also known as classic hallucinogens, are a family of psychoactive substances that exert their subjective effects primarily by organism or partial organism of serotonin receptors. Psychedelics include molecules found in the natural world, such as psilocybin and mescaline, for example. And psychedelics also include many synthetic compounds, such as lysergic acid diethylamide, LSD, and phenylalanine. The subjective effects of psychedelics are complex and multifaceted, including visual and auditory distortions and complex close-eyed visions, profound changes in emotions and mood, heightened sensitivity to internal and external context, and at higher doses, dramatic alteration of self-consciousness known as drug-induced ego dissolution. So, next slide, please. Recent fMRI, psilocybin, and ayahuasca study found significant reductions, decreasing in activity across many brain areas, including prefrontal and temporal cortical regions, as well as halves of the DMN. fMRI studies also reveal alteration of resting state functional connectivity in key nodes of DMN after administration of psilocybin, ayahuasca, and LSD. Researchers found increased integration functional connectivity between cortical regions under ayahuasca, psilocybin, and LSD. Also, psychedelics have been shown to decrease activity in the prefrontal cortex. Aside from changes in cerebral blood flow in these regions, psilocybin, ayahuasca, and LSD have also been consistently linked to decreased functional integrity of the DNA. This observation is also confirmed by EEG data. An absolute decrease in EEG power in all frequency bands was observed in prefrontal areas during the administration of ayahuasca and psilocybin. Next slide, please. So, we discussed the neurophysiological correlates of the creativity, meditation, and psychoactive substances. Now, it's time to consider whether they have anything in common, so that we can integrate this data into some kind of consistent concept, if it's possible. From my point of view, all these altered states of consciousness share two important things. First, the altered states of consciousness activate almost the whole brain. Secondly, all the altered states of consciousness deactivate the prefrontal cortex to a certain degree. So we can propose that transient hypofrontality is the unifying feature of all altered states of consciousness. It can be explained in the mainstream of critically based concepts. The criticality hypothesis of consciousness proposes that a healthy conscious brain self-organizes into a critical state, a critical point, which optimizes information processing. The key structure for maintaining these processes is the prefrontal cortex, which is a central structural region that contains executive functions such as planning, solving, working memory, cognition, and social control. It collects information from the environment and uses it intelligently to support thought processes, actions, and decisions. It manages emotions by inhibiting wrong thoughts, actions, and feelings. Conversely, deviations from this critical state are hypothesized to give rise to both pathological, for example, coma, and non-pathological altered state of consciousness, as well as changing in the brain's optimal information processing capacity. And next slide. So let me do some final remarks. The history of science shows an intensive ongoing debate about the position of scientific inquiries with respect to the study of consciousness. As a matter of fact, until recently, the largest part of the scientific community did not consider consciousness as a suitable topic for investigation, while the ultimate nature of consciousness is still full of mysteries. It is evident that deepening our knowledge of the mechanistic, statistical, and dynamical relationship within the brain in its different possible states of consciousness can only increase our understanding of the relationship between mind, consciousness, and body. A key factor supporting the modern discipline of consciousness research is the extraordinary development of neuroimaging technologies that has occurred over the last decades, which plays a fundamental role. However, making progress in the problem of consciousness not only depends on technological advances, but also on our capacity to explore and chart the contents and boundaries of consciousness itself. Consciousness research needs neuroimaging technique, but also it needs to use new methods to study consciousness and altered states of consciousness, like, for example, GDV. And I hope that systematic scientific research of altered states of consciousness may help us better understand the biophysical, informational, and dynamical foundations of consciousness. So, thank you for your attention.